Alright, today's lesson is 4-1. Our objectives for today are relating graphs to situations, sketching graphs to represent a situation, and writing a situation for a graph. It says helpful hint. When sketching or interpreting a graph, pay close attention to the label on each axis. Alright, you have a notes handout. Please make sure that you're filling out this notes handout in pencil. I want you to go ahead and read through these first 5 that I'm going to put up and find the little box that's on your handout, and I want you to go ahead and try to guess whether 1, 2, 3, 4, or 5 is going to be A, B, C, D, or E.
All right, so just so we're clear, this is the box right here that you're looking at on your notes handout. These graphs down here at the bottom are not on your notes handout anywhere, so don't get confused about that, okay? You're just looking at this box right here on your notes handout.
Alright, so go ahead and take a minute. I'm going to read each of the 5, and you're going to pick whether you think it's graph A, B, C, D, or E. Number 1 says, we rode a roller coaster steadily to the top. Then we went faster and faster as we went down the other side. Take a minute again, see if you think it's A, B, C, D, or E. And also look, make sure where down here it says talking about time. Time is always going to be your horizontal axis. Your vertical axis here is the dependent variable. And on number 1, I'm telling you that the dependent variable is talking about speed. Okay, so what's in the red on each one is talking about the independent or the dependent variable. Number 2 says a balloon was blown up in class and then let go. It flew around the room. Your dependent variable is the amount of air in the balloon. So take a minute to see whether or not you think that goes with A, B, C, D, or E. Number 3 says I turned the oven on. When it was hot, I put in the cake and it baked for about 30 minutes. I turned the oven off and removed the cake. Your dependent variable here is the oven temperature. Take a minute, see whether you think it's A, B, C, D, or E. Number 4, we bought a pair of rabbits last year. They had several litters, and we have so many rabbits that the pens are full. Your dependent variable here is the number of rabbits. Number 5, I put water in the ice cube tray and put it in the freezer. Your dependent variable here is the temperature of the water. Take a few more minutes, make sure that you have A, B, C, D, or E written for each one of the 5. Alright, hopefully you've tried these on your own. We're going to talk about which one goes with which. The first one says, we rode the roller coaster steadily to the top. So this one is going to be C. Now, a lot of you may have put A because it looks more like a roller coaster, but think about it, you're talking about speed. So when it says the roller coaster steadily to the top, that means that the speed stayed the same here. And then they went faster and faster as they went down the other side. So my speed of the roller coaster is then going to go up very, very quickly. So the speed's going to stay the same. Then the speed's going to go up. So number 1 is C. If you did not get C, please erase what you wrote and write the correct answer. Number 2 is A, because it's talking about the air. As the balloon is being blown up, the air in the balloon is going up. And then it says, then it was let go. So then the air in the balloon is going to quickly go down. So number 2 is A. Please make sure if you don't have A, that you write the correct answer.
I think typically a lot of times people want to put E here, but don't get confused about E because there is no more air going into the balloon, and in E you can see that it goes up and down, which would mean that there would be more air going into the balloon after it had already been let go, and that's impossible. So I think this looks kind of like what we think of when we see a cartoon balloon flying around a room, but it is A because the air went in and the air came out.
Alright, number 3 is E. We're talking about the oven temperature. When we turned the oven on, the temperature of the oven went up. And then when we put the cookies in, that's what an oven usually does. is it's going to go down until it hits that temperature, and then it's going to go back up, and then it's going to go back down to try to keep a steady temperature here. And then when we took the cake, sorry, the cake, not the cookies, the cake out of the oven, the temperature then went down. So number 3 is E. Number 4 is B, because the number of rabbits are going to continuously go up very, very quickly, because that's what happens when you have litters of rabbits.
Another indication there that it was B is at the end when it said that the pens are full, and B shows that you're actually out of graph line there. It's totally full.
Okay. And finally, number 5 is D. You put the ice cube tray and put it in the freezer. The temperature of the water is going to keep going down, down, down until it reaches 0. Go ahead and make sure that you have each one of those and they are correct before you move on.
Go ahead and write the number out beside that box that you had to correct as we went over those. If you got all 5 of them right, then that's awesome. Just put a little check mark next to it, but however many you had to correct, if you had to correct any of those as we went over them, go ahead and put that number out to the side of the box.
Alright, now we're going to take a look at a few more of these, but we're going to actually just be looking at your note sheet here. So we're going to look right here at number 6, and it says, each day several leaves fall from a tree. One day, a gust of wind blows off many leaves. Eventually, there are no more leaves on the tree. So look at your graphs, A, B, and C, and we're going to pick whether we think that that graph is graph A, graph B, or graph C. And if you notice, our dependent variable here is the leaves, and our independent variable is time. So go ahead and take a minute and pick whether you think it's A, B, or C. Okay. For this one, it says each day several leaves fall from the tree. So the number of leaves on the tree is going to start out high. On graph A, it's saying that the number of leaves increase. Nowhere in the paragraph did it talk about the number of leaves increasing, so it is not A, so it's got to be B or C. Then it says for B that the number of leaves went down, and then it went down even more. On C, it's saying the number of leaves went down, and then the number of leaves stayed the same, and then the number of leaves went down. Nowhere in here did it talk about the number of leaves staying the same. So our correct answer is graph B. So go ahead and put a box or a circle around graph B, because that one is graph B. Alright, number 7 says the air temperature increased steadily for several hours and then remained constant. At the end of the day, the temperature increased slightly before dropping sharply. Choose the graph that best represents this situation. So I'm right here at number 7, and we're going to pick whether we think that's graph A, graph B, or graph C. So go ahead and take a minute, see what you think about it, see if you think it's graph A, B, or C. Alright, hopefully you've had a chance to check and see which one you think it is. This one is actually going to be graph C. The reason that it's graph C, it says the air temperature increased steadily, so it went up at a constant rate of change. And then it remained constant, meaning that the temperature did not change. Then it says it increased slightly, and then it dropped sharply. So that's why it is graph C. Graph B would not be it, because it doesn't talk anywhere here. It just says it stays the same and then it dropped. In our story over here, it said that it increased steadily and then dropped sharply. Okay, make sure you have graph B for number 6 and graph C for number 7. Now we're going to take a look at number 8. In number 8, we have 3 different scenarios here, and we have 4 different graphs over to the right. And we're going to try to match up which graph goes with each scenario. So again, I want you to take a minute and figure out which one you think it is first for all 3 scenarios. The first one up here says, I left home, realized I had forgotten my backpack, and then went back to get it. The middle one says, on the way to school, I stopped to get breakfast. And the third one says, I started out calmly but sped up when I realized I was going to be late.
Make sure that you're aware that your dependent variable, so your vertical axis, represents the distance from home.
Again, so think about that as distance from home. We're not talking about the speed here. We're talking about the distance from home. All right, hopefully you've had a minute, or pause the video if you needed to try that one. This one, the first one, is going to be this one right here. The second one is going to be number 2. So we've got 1, 2, 3, and 4. So the first one is 4. The second one is 2. And the third one is that first one right there. And let's talk about why it is. The first one says, I left home, realized I forgot my backpack, and went back to get it. So with this one, when she left home, her distance from home went up. But then here she realized that she forgot her, or they forgot their backpack. When they had to go back to their house to get it, their distance from home went back down because she's at home. It took her a while to find her backpack, so she's at home. And then she went back to school, so then it went back to the distance from home. On the second one, on the way to school, I stopped to get breakfast. That one's number 2 because their distance from home increased. When they stopped to get breakfast, their distance from home stayed the same because they weren't going any farther from home. And then after breakfast, their distance from home got even further whenever they started back to school. So then this third one, it says, I started out calmly but sped up when I realized I was going to be late. So this one, the distance from home is going to continuously go up. But it's going to go up faster whenever she realized that she was going to be late, or when they realized that they were going to be late. This one basically says that they started out going really fast and then they slowed down. So that one would not have been it. Here, they started out kind of slowly and then they sped up when they realized they were going to be late. Take a minute, make sure you have all of those correct before you move on.
Okay, so now we've covered our first objective, which is relating graphs to situations. Our second objective that we're looking at is sketching graphs to represent a situation. So instead of just matching up a graph with a situation, now we're going to look at actually being able to draw a graph from a story that's been given. When we talk about graphing relationships, some graphs are connected lines or curves. They are called continuous graphs. An easy way to remember this might be to think that the continuous graph, the line continues on. Some graphs are only distinct points, and they are called discrete graphs. This part is not on your handout. I just need you to pay attention to this. The graph on theme park attendance is an example of a discrete graph. It consists of distinct points because each year is distinct, and people are counted in whole numbers only. The values between whole numbers are not included since they have no meaning for the situation. You cannot have a half a person. So you're going to use a discrete graph in an instance where you're graphing something that you can't have a half of. Like you're not going to count a half of a book or a half of a puppy or a half of a person. So just so you know, when you have to have a distinct point, a distinct specific point on your graph, and it's not an in-between type of relationship like miles per hour. You could be in between at any point in time certain miles per hour. You have to have a discrete graph to show distinct points like people or puppies or books, and you'll have a continuous graph, a continuing line, when it's anywhere in between like measurements or miles per hour or gallons of water or something like that. Alright, for number 9, it says sketch a graph for the situation. Tell whether the graph is continuous or discrete. We're going to look at this on your handout. Alright, so here we have number 9. It says a truck driver enters a street, drives at a constant speed, stops at a light, and then continues. The first thing we're going to do is break down this text into specific points where our graph is going to be changing, and then we're going to look at what our graph specifically looks like based on that text. So it says here, a driver enters the street. So the speed initially increases. Because when you enter a street, your speed is going to increase. So write the word increases there in the blank. The speed initially increases. Drives at a constant speed means the speed remains constant. So write the word constant there in that blank. Drives at a constant speed means the speed stays the same. Stops at a light. The speed decreases. Decreases to a stop. Write the word decreases in that blank. And then continues. So the speed increases again. The speed increases again there and then is constant. We're going to graph this whole situation down here in this graph just below where we've written our sentences. So we're going to go right here, okay? The first thing we're going to do is look at our independent and dependent variables on our y and our x-axis. Our x-axis, like Ms. Singh mentioned earlier, is always going to be our time, okay? It may not be specifically the word time, but it's always going to be some form of time. Hours, minutes, months, years, days. It can be a variety of things, but it's always going to represent time. So for this graph, we're just going to write the word time there. Our dependent variable is the thing that's changing. It's changing based on how much time has elapsed. So on our dependent variable for this story about the truck driver, it's going to be speed. So you need to label your axis, speed, and time. We're going to give our graph a name. That's why you have this extra blank up here, and we're just going to call this truck driver. Truck driver. Now let's look at what our graph looks like. It says the truck enters the street, and we wrote that the speed initially increases. So let's draw a line to show that the speed goes up. The driver drives at a constant speed, so the speed stays constant, so we draw a line to show that it stays constant. He slows to a stop, so he decreases and goes all the way down to 0. Obviously, when you stop at a light, you don't instantly start again as a general rule. So we're going to show that he has stopped for a little while by drawing a little bit of a line on our axis there at 0. Then his speed increases again, and he continues on at a constant rate of speed. That line should be straight there. Okay? This is what your graph should look like. So go ahead and get your graph filled in. And then we'll discuss whether it's continuous or discrete. As I said just a minute ago, with miles per hour or anything that can have in-between units, it's going to be a discrete graph. It's going to be a continuous graph. I'm so sorry. You can see here that my line is continuous. The line continues on. And this is a continuous graph. So we're going to write here continuous, excuse me. Okay, sorry about that error there. Make sure that you have continuous in here. I'm sorry, I had made an error in spelling it there. C-O-N-T-I-N-U-O-U-S. All right, so now we're going to look at number 10. It says a small bookstore sold 5 to 8 books each day for 7 days. We're going to look at sketching a graph from this situation, and then we're going to tell whether the graph is continuous or discrete. So the first thing we're going to do is go ahead and title this graph. This is going to be book sales. So go ahead and title this graph book sales. And then we're going to label our independent axis. Now again, our independent axis is always time. Time marches on. Time is independent, and it continues on no matter what we do. So here it is going to be time, but because we're looking specifically at each day, we're going to say days for our independent axis down here. And we know that we're dealing with 7 days, so I'm going to go ahead and label 1, 2, 3, 4, 5, 6, 7, and then I'll just say 8 here because that would be the 8th day. Now up here we're looking at how many books were sold each day. So we're going to label our dependent axis books sold, because the number of books sold depends on how many days have passed. So we know that we're selling between 5 to 8 books each day. So I can go ahead and label this axis. This would be 0, 1, 2, 3, 4, 5, 6, 7, 8. The reason I need to know how many I need is because I might have to count my axis by 2s, but because this axis does go from 0 to 8, I'm good. I have enough blanks there. I want you to go ahead and draw this table of data for me. We're going to have our X and our Y. Your X is always going to represent your independent variable, and your Y is always going to represent your dependent variable. So go ahead and label your axes as well. Put an X here and a Y here. So my X I know is representing my days, so I can simply write 1 through 7. 1, 2, 3, 4, 5, 6, 7. And I'm going to draw a line to separate those. I want you to fill in this table on your own paper. On day 1, they sold 5 books. On day 2, 5 books. On day 3, 6 books. On day 4, 7. Day 5, 7 books. Day 6, 6 books. And day 7, 5 books. So now we're going to graph these numbers of books. So we're going to go to day 1. On day 1, they sold 5 books. So I'm going to say day 1 and 5 and make a point. Day 2, they sold 5 books. Day 2, 5, make a point. Day 3, they sold 6. Day 3, 6, and make a point. Day 4, they sold 7. Day 4, 7, make a point. Day 5, they sold 7. Day 6, they sold 6. And day 7, they sold 5. I'm not going to connect my dots because I'm not saying that at day 2.5 they sold 5.5 books. I'm saying they distinctly sold 5 books on day 2 and 6 books on day 3. There is no in between, so I'm not going to continue this line from dot to dot. This is not a game of connect the dots. These are distinct points that represent the distinct number of books that they sold on that specific day. They do not sell a half a book. So this graph is discrete. It is a discrete graph, so make sure that you write the word discrete there in the blank. Get all that down before you move on. Okay, number 11 says we're going to be sketching a graph for the situation and tell whether the graph is continuous or discrete. So we're doing exactly what we've been doing thus far. The situation says, and I'm going to have you fill in the blank as I read this. Henry begins to drain a water tank by opening a valve. Then he opens another valve. Then he closes the first valve. In these blanks, we should also have a line here that says, he leaves the valve open until the tank is empty. Here we should say he leaves the valve open until the tank is empty. So go ahead and write that down. He leaves the valve open until the tank is empty. Sorry for my sloppy handwriting there. Okay, so we're going to look at exactly what's happening to the water level as time passes here. And it says here, as time passes, the water level does the following. So when Henry begins to drain a water tank by opening a valve, obviously if he's beginning to drain it, it's already full. So we're going to put this over here on this graph. We're going to label our graph the water tank. Our independent axis is going to be time. Our dependent axis is going to represent the water level. So write water level there on your y-axis and time down here on your x. Henry begins to drain the water tank by opening a valve. So the water level is going to initially decline. Then he opens another valve, so it's going to decline more rapidly. Sorry. Then he closes the first valve, so it's going to decline more slowly. So let's look at what that looks like. Eventually, he leaves the valve open until the tank is empty, so eventually we're going to go to 0. So we're going to start up here where the water level is high. And it says he begins to drain the water, so it drains very slowly at first. Then he opens another valve, so it declines more rapidly. So we're going to show that by declining more rapidly. Our line comes down at a sharper rate. Then he closes the first valve, so we go back to one valve being open and it declines more slowly. And he continues at that rate until we reach 0. So you have a sharp decline, you have a slow decline, a sharp decline, and then it slowly drains out to 0. This graph has a continuous line, a line that continues on. So write the word continuous there in the blank. This graph is continuous. Okay, so make sure that you have everything written down on number 11, and we're going to go ahead and look at number 12. It says a pet store is selling puppies for $50 each. It has 8 puppies to sell. So on your graph, we've already written in the 100, 200, 300, and 400 marks, and I want you to go in and put in these half marks here to show your 50s. I know that this graph doesn't have lines that grid on out, but just for the sake of understanding that we're looking at $50 increments, I think that that will make more sense to you in the long run. We're going to label this graph puppy sales. So label this graph puppy sales. And then we're going to look at our axis. This axis is time in the form of days. And, excuse me, I'm sorry. This axis is actually puppies. I'm so sorry. This axis is going to be puppies. I know that we said that the independent axis is always going to be time. However, in this instance, we're talking about puppies sold over days. Okay, so the puppies are going to be sold no matter what. That's independent. They're going to be sold. It's a matter of how many days it's going to take to sell the puppies. And then up here, you're going to earn money based on how many puppies you sell. So that's money made. Okay, so money made or amount earned. I put money made there, okay? So we're going to look at this and say on the first day they sell 1 puppy. So that is 1 puppy for $50. By the second day, they have sold 2 puppies. So they've made $100. On the third day, they have sold 3 puppies. So that's going to be $150. Each day, they're selling another puppy. So your graph is going to continue on out. So they've sold 1, 2, 3, 4, 5. By the 6th day, 6 puppies. 7th day, 7 puppies. 8th day, 8th puppy. So they've sold a total of 8 puppies. They have 8 puppies to sell, and they're ultimately earning, we can see here, 1, 2, 3, 4, 5, 6, 7, 8. Just double checking myself. $400. They've earned $400. So the amount earned is $400. And this graph, because they can't sell a half a puppy, is a discrete graph. It's a discrete graph because they can't sell a half a puppy. Alright, so make sure you have that down before you move forward. And our last sub-objective that we're going to look at here is writing a situation for a given graph. It says, number 13, both graphs show a relationship about a child going down a slide. Which graph represents the child's distance from the ground related to time, and which graph represents the child's speed related to time? You can see here that this one looks kind of like a slide. We have to look and see which one represents distance and which one represents speed. So we have distance here and speed here. If you start at the top of the slide and you get closer to the ground and then you ultimately end up at the ground, that it shows your distance from the ground. So this one is distance. And this one, starting at the top of the slide, your speed is 0. And then as you go down the slide, your speed increases greatly. And then as you get to the bottom of the slide, your speed drastically drops off and stops. So this one is measuring speed. Both are measuring over time, but you have distance and time here, speed and time here. For number 14 and 15, you're going to complete these on your own tonight, and you're going to be ready to present your possible situation for each of the given graphs. When you get to class tomorrow, we're going to ask you to share these. So you need to write at least one sentence for each portion of the graph. Each time the graph changes sharply, you're going to have an explanation for that. Please use something other than what we've given you here, like water level, a slide, or a truck traveling. Try to come up with something creative, your own school-appropriate situation for each of the given graphs. So for the first one, you're going to write a situation about speed and time. So it could be walking, running, driving, something related to speed and time. And then for 15, you're going to look at height and time. Okay, so just make sure that you're aware that this is speed and time and height and time, and write your own situations on this paper, and we're going to ask you to share those when you come to class tomorrow. This is the end of your video. Thank you for watching.